Now, I'm going to talk to you today about sea level change. And when I tell people that I study sea level, they generally think that I'm an oceanographer, that I study the water, that I went to the beach when I was growing up. But that's actually not at all the case. I grew up in the mountains. I would pick a hike in the mountains over a stroll on the beach any day. I like to climb up rock faces. And it turns out that my research is also mostly about rocks. It's about analyzing rocks and modeling how rocks deform, not just the rocks we see out front, but the rocks hundreds and thousands of kilometers underneath our feet. And what does that have to do with sea level change? Well, we don't have to go very far to understand what it does. If we go to Battery Park in New York, you'll find this tide gauge station. This is a station that has been measuring sea level change for over 150 years. And if we look at how much sea level has changed in New York over the past 100 years, what we find is that it's risen by maybe up to 12 inches, maybe about a foot. Now, if you go around the world and look at how much ice sheets have melted during that time period, how much thermal expansion has contributed to sea level rise, and you tally all of that up, you don't end up with a foot. You end up with just 8 inches, so quite a bit less than what we observe in New York. So where does that difference come from? Well, I already told you about it at the beginning. It has to do with rock deformation. It's because the land that we're standing on and living on is subsiding, it's going down. The land is sinking. And this isn't just happening in New York, it's happening all along the US East Coast. Why does that happen? We have to go back about 25,000 years to figure that out. During that time period was the last ice age, the last glacial maximum, and massive ice sheets covered the northern hemisphere, like the Laurentide ice sheet that covered Canada and the northern US. And this was, as you can see, a massive ice sheet. It was also super thick. At the thickest point, it was maybe up to the size of half of Mount Everest today. And so all of that weight pushes down and pushed down on the Earth's surface. And the areas around the ice sheet were lifted up at the same time. So it's kind of like a squishy toy that you squeeze between your fingers. Your fingers are the ice sheet, and the material bulging out around your fingers is the area, it's the US East Coast, it's the area around the ice sheet that's coming up. As these ice sheets melted, you have the opposite effect. The land rises underneath the ice sheet, or where the ice sheet used to be, and the area around the ice sheet is slowly starting to come down. Now, this ice sheet has been gone for thousands of years, but the slow creeping of the rock, the slow deformation of the rock is still going on, bringing the US East Coast down. Now, these interactions between the Earth deforming, ice sheets growing, sea level changing was very fascinating to me, and so I studied that for my PhD. My background is in physics, so I did a lot of modeling of these physical processes and interactions. And the data that I used were data that came generally in Excel sheets that looked something like this. I had a location, I had an elevation of sea level in the past, and I had an age for each data point. And I knew what to do with that, and I knew what to do with my models, so I did most of my research during my PhD. But then towards the end of my PhD, I had the chance, actually, with some people from Lamont, to go out into the field. And we went to Bermuda to look at where some of these data actually come from. In Bermuda, we studied rocks that are 120,000 years old. And so I tagged along with a few professors, a few graduate students. And I remember first day, we all got into the vans. We drove to the first outcrop, we got out, and we looked at the rocks. And I remember thinking, like, how does this piece of rock turn into a data point in my Excel sheet? And while I was standing there not really exactly sure what I was looking at, everyone else was getting into it. They got out their little hand lenses to look at the changes in grain size. They got out their rock hammers to pick off little pieces of rock and look at them. They traced different lines in the rock, and they took a lot of notes. Over the course of this trip, I also started to learn the language of the rock, and I started to understand what to look for. We were looking for features that you find at the beach today, but frozen in the geologic record. So such as ripples that you see on the top here, fossil corals at the bottom. And I also started to take more and more notes. I also learned that beds that are flat-lying, like the ones at the bottom here, form at the beach or slightly below the beach, whereas steeply dipping beds, like the ones at the top, form by dunes that are above sea level. And so there are lots of different clues and puzzle pieces about how high sea level was and how it had changed. But putting it together into one number still seemed difficult to me. At that point, though, I wasn't the only one struggling. The professors were discussing how everything fits together, so were the graduate students. And it's kind of like a jigsaw puzzle where you don't have the box, you don't know what it looks like, and half of the pieces are missing. And so you're trying to kind of piece together how everything fits together, and people come up with different interpretations of how it does. We kept discussing this at the outcrop, at the Airbnb, at dinner, at breakfast the next morning, and we still talk about these outcrops today. At the end of this trip, I kind of had mixed feelings. On the one hand side, I had kind of awe for how much we can actually learn from rocks. But on the other hand, I was a little worried about the validity of my data in the Excel spreadsheets. And one thing that really kind of sunk in during this trip is that data aren't facts. They're just the sum of a huge amount of knowledge paired with assumptions and interpretations. Now, since this trip, I've been doing more modeling modeling of rock deformation to better include these data. I've been to more islands, we've been to the Bahamas, we've been to Barbados to pick up more puzzle pieces and clues about how high sea level was 120,000 years ago. Now, I haven't told you yet why we even care about this time. 120,000 years ago, that's a very long time ago, right? But it turns out it's the last time in Earth's history when temperatures were slightly warmer than today, 2-3 degrees Fahrenheit warmer than pre-industrial temperatures. And as such, this is a great time to study because we can understand how much sea level will rise, how much ice sheets will melt as warming progresses in the past, but also into the future. And what we find doing this work is that even small amounts of warming can cause meter-scale sea level rise. But that doesn't happen from one day to the next. So what does this mean for us? What does it mean for me and you? How much sea level is going to rise in the next 10, 50, and 100 years? Now, in part, this will depend on what we do as a society in terms of emitting greenhouse gases and warming the planet. But if we continue of our current emission track, the predictions are that sea level might rise by 3 feet, maybe 4, maybe 5 feet by the end of this century. And this is quite a big difference, right? If you're building a building at the waterfront, if you're building a subway entrance, a park, you need to know now how much sea level will rise in the near future. And if we think about, is it 3 feet or is it 5 feet? One thing we can think back to is that also these data points aren't facts. They're built on a huge amount of knowledge combined with assumptions and interpretations. And if we think to the rock outcrop and all the missing puzzle pieces and the deformation of rock beneath our feet, that we need to know all of the material properties of that, it's not so much a question of how do we not know this better, why do we not know that it's 3 or 4 or 5 or 6? But for me, it's pretty amazing that we know anything at all. Thank you very much.